So something new that's recently come out, and you can see this was a letter from California ISO going out to various companies out there that are tied from a generation standpoint. They are saying that they are asking now for having digital fault recorders installed for equipment, capture high-speed data, and then also so that the industry, from a standpoint of NERC reliability and WEC standards, are meeting WEC. So what kind of precipitated this particular event and this particular letter going out is the Odessa event that happened out here in Texas in 2021 and then 2022. There's a fault on a 345 system, but then during that fault, we ended up losing a lot of inverter-based resource, IBRs, inverters that just actually tripped out either on high voltage or something, but they lost, gigawatts worth of generation during that event. They're trying to figure out what's going on, but be able to do that, NERC being able to do that and look at everything and within the various reliability areas. So this one was WEC, associated with WEC, but there's also, of course, Texas RE, NPCC, CERC. So all the different regions are kind of looking at this and saying, we need some data to make sure we're capturing this information. And that's kind of where this device, where the Fischer Block will actually come in and record that information, be able to get the information so they can look at it. Correct?
That's right. Our platform, we're measuring electrical signals in very high resolution, picking up and capturing oscillography, which is part of the DFR. We're also capturing all of the phaser units as well. And what NERC and California ISO are focused on is if an IBR resource trips offline, they want to be able to do the diagnostics and determine if it was a valid trip, if it was too sensitive, what have you. And without that oscillography captured, they're in the dark. And so this is a great opportunity for IBR owners and operators to comply with the direction that the industry is going, and being able to capture that oscillography and ensure that their farm and resource is compliant. It's not tripping too, when it shouldn't be. And if there is an issue, that it can then be resolved in, a very positive, efficient way. So we're very happy to be able to support this new initiative.
Yeah, to be able to analyze, you have to get the data in to be able to analyze that information. And yes, that's actually very big. So this really, anybody that has an IBR, which is going to be solar facilities and battery facilities, and to some degree some wind, but they've actually NERC is kind of saying not so much on the wind right now, but those are two big ones, and we're still growing. There's still a lot of battery sites going in. There's a lot of solar still going in. So this would be very, very useful. And it's also very, again, easy to backfit this and put this into older plants for this recording.
Right. And I think that, wind is going to be part of that. I think going forward, it seems like 5 megawatts, some type of is a threshold that might be looked at, which is, just a few wind turbines. So that's another area that makes sense to capture oscillography. This example here of solar, definitely an IBR, and the high resolution monitoring allows all of the harmonic detection there, that last bullet on both the AC and DC side. That provides the oscillography feature that handles the NERC and the ISO recommendation. But other than that, the situation where if you do have a ground fault on a solar farm, some of the utility scale are such that technicians go out and need to walk several miles of panels physically inspecting while it's offline to determine, which string or which panel caused the ground fault based on some type of a physical indication, cracked panel or burn marks towards the frame and so forth. However, by monitoring these lines in high resolution with a system such as ours, in the event of a ground fault, we're able to then provide a very short distance, several hundred feet maybe is all, rather than several miles. So the technician very quickly can then go and isolate the fault, confirm it with portable equipment, and then get that panel swapped out and get the generation going much quicker. And so that's a big area of opportunity. And then also utility scale projects and farms. When there is a faulted panel or a panel that's beginning to degrade and it needs to go on watch, for example, physically, it's very difficult sometimes to get back to these panels because every panel looks identical and typically they're not barcoded and labeled. And so with a platform like ours provides the opportunity for geo coordination and application. So your technician goes up to a panel, takes a photo with their phone, puts in some notes, hits submit. All that goes into the database, and then that same application can be used to get back to that panel, and then also track it through its life, so that as it degrades, before catastrophic, it gets swapped out. So, solar is kind of new for a lot of folks in the industry. However, a lot of the benefits of the AC side of monitoring assets actually apply to the DC side, as I just explained. And so, all leading up to the inverter, there's quite a bit of information to keep things running smoothly, and then monitoring the AC side of the inverter for harmonic distortion, and this NERC guideline is very valuable as well.
Yeah, that kind of ties into, again, it goes right back to predictive analytics, helping keeping that facility, your facility, up running longer and more reliably. I mean, in the end, it's production. So, knowing and tracking all that information, getting it ready, that's just excellent. I mean, having a device like that can help you is just tremendous.